Telekinesis, sometimes called psychokinesis, is the ability to move objects without physical contact in any way. In fiction, it's usually depicted as being achieved via the mind, as if someone is using an invisible force to manipulate distant objects, often channeling that force through their hands or eyes. It's moving things without physically moving them, and its uses range from convenient to deadly, depending on which superhero or villain is capable of it. Despite the obvious challenges in making something like this possible then, a number of projects and experiments have already looked into potential forms of real-world telekinesis. In early 2022, for example, researchers at Carnegie Mellon University in the US managed to create what's been dubbed robotic telekinesis. In an experiment, participants were able to control a robotic hand on a table simply by moving their own hand in front of a standard camera. The camera could accurately track the user's movements and instruct the robot hand on how to mirror them, without anyone ever needing to touch the robotic hand. In one sense, experiments like these achieve the main goal by, again, moving things without physically moving them. But this perhaps still isn't pure telekinesis. The participants in the Carnegie Mellon study aren't yet directly controlling the hand with just their brain. Instead, the camera is controlling the robot as a small but crucial bridge. So, could it ever be possible for someone to truly affect the outside world around them with only their brain power? No middleman required? Seemingly, yes, it could be and is. According to a multi-authored paper published June 11, 2022 in the journal eLight, entitled Remotely Mind-Controlled Metasurface via Brainwaves, we may now be on the brink of finally making things move from afar. In the paper, brainwaves are the major controlling factor. Humans produce brainwaves as a byproduct of neurons exchanging electrical impulses in the brain, similar to how general electricity can produce an electromagnetic field. Brainwaves, like other wave types, come with wavelengths and frequencies to determine their power. As a standard rule, the longer the wavelength, the shorter the frequency, and vice versa. The least frequent and energetic brainwaves are known as delta waves, which are typically produced during sleep. Then there are theta, alpha, and beta waves, and finally gamma waves, which have the highest frequency, are the strongest, and are produced during periods of intense concentration. So, before they began, and thanks to decades worth of neurological study, the researchers aiming for telekinesis had a very sound understanding of the brain energy they were working with. But still, leading those brainwaves to affect something on the other side of the room is an all-new challenge. The team, made up of scientists from the Air Force Engineering University in China and the National University of Singapore, turned their attention to an advanced type of technology called metamaterials in a bid to solve the problem. Metamaterials are any material specifically created to have properties that don't usually occur in nature. They're pointedly artificial in one way or another, built out of tiny pieces known as meta-atoms, and designed to be wholly flexible. Importantly, metamaterials can be designed to directly interact with light and electromagnetic waves. They can be built to target specific wave types, to change how those waves behave, but also to be affected by those waves as well. And here's how we get to the remotely mind-controlled metasurface at the heart of the June 2022 telekinesis study. Metasurfaces are ultra-thin structures made from metamaterials that can control and affect electromagnetic waves, including brainwaves, that they come into contact with. The wider applications of them are limited at present, but in the context of this study, they're something of a key landing pad. In the study, participants were hooked up to devices capable of recording and collecting their brainwaves before those waves were sent via Bluetooth to a separate metasurface to have an effect. We're not talking visible movement just yet, but to deliberately disrupt the electromagnetic conditions. As those behind the experiment explain, quote, "This framework consists of 3 parts: sensor, controller, and actuator," end quote. So it might be argued that there still is a middle process required, the collecting and sending of the brainwaves. But it seemingly remains a major improvement on previous telekinesis models, including robotic telekinesis, which needs to almost translate brainwaves before they can be used. Here, it's the brainwave through and through. It's just that the wave needs to pass something of a checkpoint before it can complete its journey. Specifically, the first step in the 2022 experiment was to attach an electrode detection device called a ThinkGear AM module to the participants' heads. The module has a built-in electroencephalograph sensor, which enables it to gather any brainwaves produced. The ThinkGear module was then attached to a Bluetooth transmitter to wirelessly send the readings it had collected from the participants' heads to the metasurface. And finally, the metasurface, due again to the ability to interact with electromagnetic waves, was capable of reacting to the brainwave data. A thought on one side of the room was turned into a small but extremely significant action on the other side. Even more impressively, the experiment was able to factor in concentration levels to have an impact on results. There were 4 groups under scrutiny: distracted, neutral, concentrated, and extremely concentrated. Across these groups, participants were able to alter the intensity of brainwaves that they generated, and therefore the intensity of the energy that was then sent to the metasurface. If they were distracted, for example, their brainwaves were less energetic and had less of an impact. If they were extremely concentrated, they effectively wielded more power. And it's hoped that in the near future, smaller and more nuanced groups will be added to these first 4 to make telekinesis an even more controlled affair. Whatever the setup or conditions, though, the metasurface was found to have reacted to the participants' thoughts within 78 milliseconds, making it all but instantaneous to the human eye. So where do we go from here? This study is already tipped to inspire even more advanced forms of scientific telekinesis in the future. Other areas of research include investigating alternative ways to read brainwaves and translate the signals to make it more portable or convenient for the user. Scientists at the University of Miami, for example, have proposed a way to introduce a form of telekinesis by implanting nanoparticles inside of human neurons and using them to send the electrical impulses from neurons into outside computers that can translate and take action in the real world. In whichever way it's achieved, it's clear that there could be many major technological breakthroughs made because of telekinesis. It could make a huge difference to anyone with an artificial limb, affording direct control over a mechanical body part. It may have a big impact on home and personal security, allowing users to lock up just by thinking about it. All forms of communication could face a massive upheaval without even the need to type or say your messages out loud anymore. From the health sector to the entertainment industry, efficiency is the key driver, and it doesn't get much more efficient than simply thinking it and it's done. Meanwhile, another mind-boggling aspect of these potentially telekinetic systems of the future is that distance may eventually be irrelevant to them. Since much of the processing of our brainwaves would be wireless, there's global reach. Theoretically, you could imagine it while standing on a beach in North America, and whatever it is could happen moments later in a city in Europe. Right now, it's a technology that's still very much in its infancy, but how far do you think it could go? And how important do you consider this most recent breakthrough to be? Of course, there's a lot of work and progress needed before we're all just walking around, snapping our fingers, and effortlessly altering the world at every corner. It's not as though everything on Earth will ever be made of 100% metamaterials. And if metasurfaces do increase over the coming years, then there's sure to be masses of legislation around them. But nevertheless, there's also a long road of possibility ahead of us if researchers continue to push this particular tech forward. And before long, rather than you needing to go to things, it'll be the things that are coming to you. Because that's how scientists may have just invented